Good everyone, my name is Graphics. In today's tutorial on fluid mechanics, we want to solve the problem that is displayed at the right hand side of the screen. And the question that backs up this problem says, freshwater and seawater flowing in parallel horizontal pipeline are connected to each other by a double U-tube manometer as illustrated in the figure above. If the density of seawater at that location is 1040 kg per meter cube, determine the pressure difference between the two pipelines. Take density of mercury to be equals to 13,600 kg per meter cube and density of water to be equals to 1000 kg per meter cube. Now, if you look at the figure closely, we are told it is what? A double U-tube manometer, which is a differential manometer here, right? The first thing we have to do in this figure is to write out the parameters to ensure us work effectively. So let me start writing them out. The first parameter here given will be that for what? For the freshwater. And we say that the density of the freshwater, which is given as rho W, is 1000 kg per meter cube. The height of the water, which you can see that is situated at the left limb of the freshwater manometer there, is given as what? 0.5 meters. Right? We use H sub W to represent that. Now, the next one is now for seawater. So the density of the seawater here is given as 1040 kg per meter cube. Right? We use rho sub SW. And the height of the seawater here is given as 35 centimeter. So if I convert it to meter, we'll be having 0.35 meter. Right? These are what we have here. So if you look at it, we are not given that of air because the air is very small and negligible. So we ignore it. Is that okay now? So let's proceed. Now, if you look at the manometer closely, right, we need to write out the equation that will make our work easier. Is that taken? So if you look at the manometer closely, we have different sections. This section you see here where my arrow is pointing is that of the freshwater. You see the freshwater here flowing in this direction, and this is the height of the freshwater, which is already given. And if you look at this from here to here, that is the space the mercury occupies, right? And the height between this point and this point, which is the height of the mercury, is given, which I've already given them my parameter, which is seen to be what? 8 centimeter, right? And that is will give us 0.08 meters. That is the height of what? Of the mercury, right? So we move forward. Now, the height of the air given here is given to be from here to here, and that is 0.6 meters. That is the height of air. Then the height of the seawater here given, you can see from here to here, that is given as what? 35 centimeter, which is given to be 0.35 meters if you convert. So I will take the point where the water and the mercury meet to be 0.1. I'll take the point where the air and the mercury meet to be 0.2. And I'll take the point where the seawater and the air meet to be what? 0.3. Right? Now you need to understand something. We are told to look for the difference in pressure, right? The difference in pressure between the freshwater and what? And the seawater. So we say P sub W minus P sub SW. Pressure at the freshwater minus pressure at the seawater. That's the pressure difference. Are you good? Because we know that liquid flow as a result of what? Pressure difference. Now, let's proceed. Now, if you look very well, from my previous video, I make you understand that the lower you go, the deeper you go in an ocean, the higher the pressure, right? As you go down a swimming pool, the more pressure is exerted on a particular body. So meaning that the pressure at P1 here, at point 1 here, is greater than the pressure of the freshwater here, PW, right? Because the pressure at this point, we'll call it PW, and the pressure at this point, we should call it what? P1. So it is greater. So say PW is less than what? P1. Can you see that? Or I can say P1 is greater than what? PW. So we want to know, to get the pressure at PW, it will be the pressure at point 1 minus the pressure at what? At the freshwater. Let me call it maybe the tank there, or where it is connected to freshwater. And we know that's what we have there. So what is the pressure at the freshwater? We know pressure is given as what? Specific weight times what? Times height. Are we good now? Specific weight times height, that is given as pressure. In some cases, we might use small w to represent the specific weight times height. Are we there? But the specific weight, from our knowledge, is given as what? Density times gravity. So I will now input this and say that the pressure of the freshwater, P sub W, is equals to the pressure at point 1 minus, instead of me writing specific weight here, I'll be writing the density of the freshwater times gravity times the height of the what? Of the freshwater. Now if I implement this, pressure at the freshwater will now be equals to what? The pressure at point 1 minus 1000 times 9.81 will give us 9810, right? Times 0.5 will give us 4905. So this is what we have. So I'll term that my equation what? My equation 1. Is that taken? Now we'll move forward. Now if you look closely, as you move higher from point 1 to 2, right, you discover that what? The pressure reduces. So meaning that what? As you move higher a level, pressure what? Reduces. Is that taken? So meaning that still the pressure at point 1 is greater than the pressure at what? Point 2. Or we say pressure at point 2 is less than what? Pressure at point 1. Is that taken now? So my P2 here now will now be equals to, that is the pressure at point 2 will now be equals to the pressure at point 1 minus, that means to get the pressure at point 2 will be the pressure at point 1 minus what? The pressure of what? Exerted by the mercury. I will get how good now, because if you look at between point 1 and point 2 here, we're talking about the liquid mercury there. So if I do that, what is the pressure of the mercury here? That will be, you know that pressure is given as what? The specific weight times what? Times height. And we're talking about mercury here. So anywhere I see this pressure of mercury, I'm going to put specific weight times what? Times height. Is that taken? So if I move forward, I will now say that the pressure at point 2 will now be equals to pressure at point 1 minus, instead of me writing my specific weight times height, my specific weight, we know specific weight is given as what? Density times gravity. So I'm going to write in the density of the mercury times the gravity times what? The height of the mercury. Is that taken now? So this will now give me P1 minus the density of mercury is given to be 13,600 times the height times the gravity, which is 9.81, then times the height of the mercury here, which is given as what? 0.08 meter, converting a centimeter to meter. This is what we have here, as we are dividing by what? By 100. So we now see that the pressure at point 2 will now be equals to the pressure at point 1 minus, if you multiply 13,600 multiply by 9.81, how good? If you multiply them by 9.81, you are going to be having 10,673.28. That means multiplying 19,600 times 9.81 times 0.08 will give us what? 10,673.28. That's what we have. So I'll call that my equation 2. Are we good? Now we'll move forward. If you now look at point 1 and what? Point 2 and 3, that is where the air is occupying. And the density of the air is very negligible, right? It is small. So we are going to what? We are going to neglect it. So we'll just say that the pressure at point 2 here is equals to what? The pressure at point 3, because between point 2 and 3 is where the air occupies. So we say that what? They are equal. So we'll go to the next one. Now we'll not go on the seawater. Now, do you notice that the seawater is going down, right? We're moving from that point 3 downward, we're going down. So it means that what? The pressure will be getting higher. So we say that higher than state 3, right? So we now see the pressure of the seawater, right, is greater than what? The pressure at what? At point what? Point 3, which is since I'm saying point 2. If point 2 and point 3 is equal, it means that what? Point 3 is equals to, it means that what? Point 3 is equals to what? Point 2. So I write that the pressure of the seawater is greater than what? Point 2, since point 3 is equals to what? Point 2. Now, if I do the needful, I'll now say that to get the pressure of the seawater, it will be the addition of the pressure at point 2 plus what? The pressure of what? Of the seawater. And we know that pressure is given as what? Specific weight times height, right? So we will now say that the pressure of the seawater will now be equals to the pressure at point 2 plus specific weight of what? Of the seawater times the height of the seawater, right? But specific weight is given as what? Density times gravity. So if I implement this, I will now say that the pressure of the seawater will now be equals to the pressure at point 2 plus the density of the seawater times gravity times height of the seawater, right? So this will now give us, we'll now say that my pressure of the seawater will now give us P2, that is pressure at point 2, plus density of the seawater is 1040 times gravity is 9.81 times the height of the seawater is given at 35 centimeter. When you change it to meter, it will be what? Divided by 100, that will be 0.35. So we'll now say if you multiply everything, my pressure at point 2 my pressure of the seawater will now be equals to the pressure at point 2 plus 3,570.84, right? That is what we have. I'll call it my equation what? My equation 3 here. Is that taken? So now we've gotten all these things we need. The next thing we know that recall the pressure of the freshwater minus the pressure of the seawater will now give us. Now anywhere you see the pressure of the freshwater, we know from equation 1 is given as P1 minus 4905, right? I'll write it down, minus the pressure of the seawater given from what? From equation 3, we say it is given as what? P2 plus 3570.84, right? That's what we have here. But we know that P2 is given to be what? My P2 is given to be what? P1 minus 10,673.28. Are we good now? So I will now write it this way by saying that my P1 minus 4905 minus open bracket. Instead of me writing P2, I'm going to be writing P1 minus 10,673.28, right? Plus 3570.84. So if I do the needful, if I open the bracket, I'll be having P1 minus 4,905 minus P1 minus time minus give you plus 10,673.28 plus, because minus times minus will give you, minus times plus will give you plus, will give you minus, and we have 3570.84. Are we good now? So if you do the needful, you call that positive P1 will cancel out negative P1, and we're left with minus 4905 plus 10673.28 minus 3570.84. That will give us 2197.44 Pascal. Right? This is our pressure difference. So we'll now say that my PW minus P sub SW, that is the pressure of the fresh water minus pressure of the seawater, will now give us what? 2.2 kilopascal. Because when you divide what you have up here, right, by 1000, it will be left with what? 2.19, which is simply saying 2.2. So kilopascal or kilonewton per meter square. This is our answer. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.